Hello and welcome back to IB Depressed for another physics video. Today we're going to be covering the equations of motion, also known as the SUVAT or the UVAST equations. But before we do that, there's one important concept that we have to make sure is understood. This is the difference between distance and displacement. So for example, if I have point A here and I have point B here, a car is traveling from A to B on a road that looks something like this. On this road, the distance traveled is 1,000 kilometers. However, a bird, for example, would just travel directly in a straight line and would only travel perhaps 750 kilometers. And this is an example of the difference between distance and displacement. So if a car travels on the road from A to B, the distance traveled by the car is 1,000 kilometers, but the displacement of the car is only 750 kilometers, because it's the most effective way to get from A to B, essentially. Now this is important because it's distance versus displacement that is the difference between speed and velocity, where speed is equal to the distance traveled over the time and velocity is equal to the displacement over time. And these equations of motion will be using displacement and velocity. So now that we got that covered, let's dive into the equations. But before that, I just gotta erase the board quickly here. There we go. All right. So the first equation of motion that we have is V is equal to U plus AT. It looks a bit unclear, that V, so I'll just redraw it quickly. Oh, there we go. Where V is equal to the final velocity, the U is equal to initial velocity, A is equal to acceleration, and T is equal to the time. Furthermore, we also have V squared is equal to U squared plus 2AS. We have S is equal to UT plus 1/2 AT. And we have S is equal to VT minus 1/2 AT squared. I just noticed I made a mistake in the third equation. It should be S is equal to UT plus 1/2 AT squared. That is my bad. And for the last equation that we're going to be using is S is equal to 1/2 U plus V times T. And the variable S for all of these equations is equal to the displacement. Now, this is the main method that you're going to be using for solving a lot of these types of questions. However, these equations are only valid under one important condition, and that is that the acceleration has to be constant or uniform. And this also means that the air resistance has to be negligible. And if the question does not mention that, then you cannot assume it, and therefore you cannot use these equations. But which equations should you use in what case? Well, as you may have already noticed, each of these equations are missing one variable that the other ones aren't. For example, the first equation does not include the variable S. Hang on. No S in this one. No S. The second one does not include the variable T. The third one does not include the V. The fourth one does not include U. And the fifth one does not include A. So based on the information that you're given in each question, that's how you decide which of these to use. So let's go through an example now. This question is about throwing a stone from a cliff. Antonia stands at the edge of a vertical cliff and throws a stone vertically upwards. The stone leaves Antonia's hand with a speed of V is equal to 8 meters per second. The acceleration of free fall, g, is 10 meters per second, and all distance measurements are taken from the point where the stone leaves Antonia's hand. Now, the commonly accepted way to do these types of questions is to start with writing down what you have, or what you've been given in the question. So, we are given that the acceleration, a, is equal to 10 meters per second, and we're also given that the speed at which the stone leaves Antonia's hand is 8. This means that the initial velocity of the stone, u, is equal to 8 meters per second. Before we go on, there's one important distinction to be made here. The acceleration and the initial velocity appear in different directions, right? Because the acceleration will be going this way as it's attracted towards the Earth, while the initial velocity, as you can see by the black arrow, is going upwards. This means that they are in opposite directions, and thus we have to indicate that by having them have opposite signs. So in this case, we will assign the negative sign to the initial velocity, making the initial velocity negative 8 meters per second. Now, we want, as you can say here, it says, ignoring air resistance, calculate the maximum height reached by the stone. There's another bit of hidden information here, and that is the maximum height is the point at which the object no longer has any vertical velocity. This means that the final velocity in this question is 0, because that's the point we're looking for. So v is equal to 0 meters per second. And what we want is the maximum height, aka s, aka the displacement. Now looking back at our equations, let's figure out which one we should use. Hang on. Alright. What we do not have here is the time taken. This means that the first question the second equation applies here. So we will use v squared is equal to u squared plus 2as. Now, from here on out, you can rearrange the equation because we want s, so we can write it as vs is equal to v squared minus u squared over 2a. And from here, you can just plug in the values that we have. We have all the known values. So s is equal to 0 squared minus negative 8 squared over 2 times 10. S is equal to negative 64 over 20. And S is then, of course, equal to negative 3.2 meters. However, as we know, using common sense, the maximum height, that value is always positive, right? So therefore, the maximum height reached by the stone is 3.2 meters. All right. Now, moving on, looking back at the question, there is a B part. So let's just show that here. We have II next, the time taken by the stone to reach its maximum height. Okay, so this is again a continuation of what we just did. We can use the same information. So we have A is equal to 10 ms negative 2, U is equal to negative 8 ms negative 1, V is equal to 0. And we also have now that the S is equal to 3.2. And what we're looking for is the time. So let's go back to our equations and see what we should use. Now, in fact, since we have all of this information, we could use any one of these. I'm choosing to use the first one as it's the simplest and easiest to work out. So we're going to be using V is equal to U plus AT. V is equal to U plus AT. Again, from here you can rearrange to get T by itself. So T is equal to V minus U over A. From here you just plug in the values. So T is equal to 0 minus negative 8 over 10. Which gives us T is equal to 8 over 10 or 0.8 seconds. Great. Moving on, Question B, determine the height of the cliff. So let's again write down what information do we have for question B. Well, the initial velocity of the rock remains the same, and the acceleration also remains the same. So we have A is equal to 10 ms negative 2, and U is equal to negative 8, right? Oh, and there's a piece of information here that I didn't read. The time between the stone leaving Antonia's hand and hitting the sea is 3 seconds. Okay, so we're also given the time. The time is 3 seconds. And we want the height of the cliff. So again, we want the displacement s. What we're not given is the final velocity, as it's no longer 0 because we're now traveling downwards. So let's look at what we have. We don't have the final velocity, so we should be using an equation which doesn't involve v. That would be this third equation here. S is equal to ut plus 1/2 at squared. S is equal to ut plus 1/2 at squared. From here, we just we don't have to rearrange this case because we're looking for s, so we can just put in the values. S is equal to negative 8 times 3 plus 1/2, sorry, just like to do this, 1/2 times 10 times 3 squared, which through some mental arithmetic is negative 24 plus 45, which is equal to 21 meters. Therefore, the height of the cliff is 21 meters. Great. Now we have that solved.